Good morning, everyone. Welcome back to Elementary Algebra 098. We are going to continue working through our guided notes on graphing. So last class, we talked about graphing horizontal and vertical lines. We learned that anytime you had an equation where it was x equals a number, so x equals a constant, like x equals a -5, or x is equal to 2, we know that that's going to represent a vertical line on the graph. We also learned that if you had y equals a constant, so something like y equals -1 or y is equal to 10, that represented a horizontal line. So we're going to continue with this understanding. We have another example to make sure that we know how to solve the equation in the graph, and then we're going to get into slope of a line. We're essentially building up the skills that we need to be able to graph using slope-intercept form, which honestly is my favorite way to graph. It's the method that I use for whenever I graph linear equations, and I think you'll see pretty quickly why that is. So what you're about to learn, you really want to get very good at graphing using this technique, because you will find it's so nice. It's just so nice. Good morning, Johanna. Let's take a look. We left off on number 2. We had 1/7y plus 1 is equal to 0. So I'm hopeful that when you all brought this home and you tried this on your own, you said to yourselves, okay, well, first things first, I know that I need to isolate the indicated variable. So I'm going to subtract 1 from both sides. And that leaves me with 1/7y is equal to, notice 1 minus 1, they cancel each other out, leaving us with 0. So a 7th y plus 0 is still 1/7 y. And then 0 take away 1, or 0 minus 1 is -1. All right, beautiful. Now recall our techniques. Whenever we have fractions in our equation, we can multiply by the LCD to eliminate fractions. So we're going to multiply both sides at this point by 7. That's our LCD. Notice on the left-hand side of the equation, your 7s are going to divide each other out, leaving you with 1. So we have 1 times y, which is 1y, or simply y. And then we have -1 times 7, which is -7. So as we think about graphing something like this, recall that it may be helpful to you to take the first step. The first step would be to say, where is y equal to -7? And then you think about, oh, and Claire, this is on page 6. Excellent question. This is on page 6 of 15. So when you think about where in the heck is y equal to -7, so you go to the y-axis and you say, okay, well, if I follow this y-axis, I have 0, -1, -2, -3, -4, -5, -6, -7. And we're going to plot that point right here. And we're thinking to ourselves, surely y has to be -7 at that point. Well, the ordered pair corresponding to that point is 0, -7, right? Every ordered pair is of the form x then y. It's an ordered pair, x coordinate followed by the y coordinate, alphabetical order. Now, we always need 2 points to make a line. So essentially, we're going to come up with another ordered pair, but we have to note that y is -7. This is like a command, right? They're saying, I don't care, they, whoever they is, I don't care what you define x, but what you must know is that y is -7. So when I come up with a second ordered pair, I know that y has to be -7. And there's no two ways about it, right? You have to write down that y is -7, which implies that any number your heart desires can go in this x coordinate. So I'm just going to put 2. So then I'm going to plot the point 2, -7, and notice that'll give me a horizontal line, which you know should be what you're expecting simply because it's of the form y is equal to a constant. So make that nice and visible, and then there's our equation, y is equal to -7. That is our line. Continue to practice this concept with the horizontal and vertical lines. If you're ever left with just one variable, you should know every time you have x is equal to a constant, that's vertical. Every time you have y is equal to a constant, that's horizontal. Okay, Next, I want to talk to you about the slope of a line. So first off, when you think of slope, I want you to think rise over run or fall over run. Now remember that when you read a graph, and I'm going to make a note here, we read graphs from left to right. Okay? Always read graphs from left to right, in the same direction you would read written English. So what slope is essentially saying is that we are going to calculate the change in y and put that over the change in x, right? So I want you to think about the fact that when the numerator tells you you rise or fall, you're essentially changing in y. But then when you're running, you're changing in x. Does that make sense? X is your horizontal axis where y is your vertical axis. So vertical change, rise or fall. Horizontal change, run. Change in y over change in x. More specifically, if I wanted to calculate the slope between any 2 points, I would use this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Recall that we need 2 points to make a line. So if I want to calculate the slope between those 2 points, I'm going to label my first ordered pair x sub 1, y sub 1, because it's my first point. And then my second ordered pair, I'm going to label x sub 2, y sub 2, because it's my second point. Hopefully that makes sense. I want to show you that in action. But before we begin, I want to take a sneak peek at our previous graph. So these are on a previous page. We were graphing by finding the intercepts, and we had these lines. So what I'd like to do for a moment is show you how to read this graph. So for instance, number 1 has this particular graph where if we were to, let's say, approach the graph from the left, right? We approach from the left, we move to the right. We're essentially moving the same way we read written English. When we hit that line, notice what happens. If I follow the line, what's happening? I'm going uphill. Do you see how when I read from left to right, I hit the line, and now I'm going to follow it, and I'm going uphill. So because I recognize that I'm moving uphill, this is positive slope. I am rising, correct? If we wanted to get a little bit closer to view what's happening here, let's get a little bit closer. Let's say I wanted to calculate the slope from this point to the next point, right? Remember, we're going uphill here, as we can see. So we move from this point to the next. In order to do that, do you see here we have to rise 1, 2 units and then run 1, 2, 3, 4, 5, 6 units? Let me show you. We would have to rise 1, 2, and then we run 1, 2, 3, 4, 5, 6. So the slope in this case, we rose 2, ran 6. That means your slope is actually 1 over 3. Cool, right? I'm going to apply the slope of 1 over 3 to this point just so I can prove to you that we're still on the line. So from this point, this is my starting point, I'm going to apply the slope. Rise 1, run 3. 1, 2, 3. And what do you know? I'm on the line. Rise 1, run 1, 2, 3. I'm on the line. Let's do it again. Rise 1, run 1, 2, 3. I'm on the line. So every time I do this, I find yet another point on that line by simply applying the slope. And we could do that an infinite number of times. I like to move from integer coordinates to integer coordinates so that it's easier to plot these points. Let's look at number 2. For number 2, recognize that, again, I'm going to read this from left to right. So I'm going to approach from the left, approach, approach, approach. Oh, I hit the line and look what happens. I'm going downhill. So because I am moving downhill, I recognize that I have a negative slope. So our previous problem was positive slope, and that was seen here because it's positive 1 over 3. For this graph, notice that I'm going downhill, so I will have negative slope, and I'm going to prove that to you. So again, we want to move from the first point to the second point, right? And I'm going to call this first one here our starting point. Now I want to move from this point to this one. So I have to go down 1 and then over 1, 2, 3, 4, 5. So I had to go down 1 unit and over 5 units. We could do that again. Down 1 over 1, 2, 3, 4, 5. Right? And that's where we cross. If you want, you could go backwards and test this. So let's go back 1, 2, 3, 4, 5, up 1. And what do you know? You found yet another point on that line. So as long as when you move from one point to the next, down 1 over 5, down 1 over 5, down 1 over 5, we can always pick a point that precedes that to make sure that we're still applying that slope. Now, before I leave this page, I want you to notice something super cool. Do you see how we wrote the slope was a -1 over 5? Look at your equation. Y is equal to -1 over 5x plus 1. The slope is right here in our equation. It's your coefficient of your x term, your linear term. Think about that as we proceed, okay? I want you to keep that in mind. Now notice this equation is in slope-intercept form. It's called that for a reason. Equation number 1 is in standard form, so it is not in slope-intercept form, which means we can't identify the slope right off the bat. But for slope-intercept form, we can. We'll get to that more in a little bit. So again, please commit this formula to memory. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now the order can actually be switched. So for instance, another version of the slope formula is y sub 1 minus y sub 2 over, you guessed it, x sub 1 minus x sub 2. As long as you're consistent, the order of those ordered pairs, meaning which point you call the first point and the second point, is negligible, right? Because you're going to get the slope between those 2 points, regardless of how you calculate this. It's actually quite interesting. So let's take a look at a couple examples and I'll show you what I mean by this. Okay, let's look at number 1. So number 1 says, plot the points on the graph provided, identify the slope graphically, then prove it algebraically. So we're going to do both of these things. We're going to identify the slope graphically, and then we're going to prove it algebraically. When we say prove it algebraically, we mean use the slope formula. That's what we mean. When we say identify the slope graphically, we mean count visually, right? We look at the graph and then we make a count. We say, do we rise over run? Do we fall over run? Let's check it out. So we have the following ordered pairs in -3, -6, and 2, 5. We're first going to begin by plotting both of these points. So -3, -6. So left 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. This is the ordered pair, -3, -6. Our second ordered pair is 2, 5. So we're going to go right 2 and up 5. 1, 2, 3, 4, 5. Here I have my 2 points. Easy enough. I'm going to take my awesome straight edge and I'm going to connect the 2 dots with a straight line as carefully as I possibly can. Okay, not bad. Draw arrows on either end, of course, to show that it continues towards infinity, and positive and negative infinity. Okay, we have our line. Success. We now want to calculate the slope. We're going to do this visually and we're going to do this algebraically. So recall in words, the slope is either rise or fall over run. Now here's how we decide what we're doing. Take your pen, approach or pencil, approach from the left until you hit the line. When you hit the line, follow it. Oh, what am I doing? I'm going uphill. So because I'm going uphill, this has positive slope, which means I'm going to rise, then run. Remember, rise is positive. So I'm going to go back to that line, and I'm going to say, okay, I want to go from this point to that point, which means I have to rise vertically, then run horizontally. So let's check this out. So from my first point here, I've got to rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I had to rise 11 units. And then we have to run 1, 2, 3, 4, 5. So according to my count, graphically, I show that the slope is 11 over 5. Okay, let's prove it. And I'm going to make a note here that we did this graphically. Now, if I'm going to prove this, it's going to help us if we label our ordered pairs. I'm going to call this first ordered pair x1, y1. I'm going to call that my first point. And here's my second point, so I'm going to call that x2, y2. So right above each coordinate, x1, y1, x2, y2. Be very careful, heed my warning, be very careful not to label your first ordered pair x1, x2. That doesn't make any sense. It can't be, because you know every ordered pair is of the form x, then y. So if you have your first point, x1, y1, your second point, x2, y2, your third point, x3, y3, and so on and so forth. And we can keep doing this all day long. So be super careful. X, then y. Always, always, always. So let's apply this slope formula. We know slope is m, as we've seen on our previous page. Slope is represented by the letter m. One of the things that I've considered explain how I can explain this to students is I always think of slope as movement. So when I see that m, I think about movement, how you get from one point to the next, right? It's almost like saying, if we start at MCC, how do I get to, I don't know, Core Life Eatery, right? You would go up a couple blocks on East Henrietta, and then you'd go right a bunch of blocks to get to Core Life Eatery. So essentially, to get from one point to the next, we applied that slope, that movement, to get north and then east, right? Rise and then run, that kind of thing. So hopefully that was helpful. Anyways, I digress. So we are going to use the slope formula. If it is helpful, let's rewrite it. y2 minus y1 over x2 minus x1. This formula needs to be committed to memory, so you're better off just writing it again and again. Hannah, excellent write-up in the chat. You are absolutely correct. I want to point out to you what Hannah wrote in the live chat. She says, well, y2 is 5. You see? Because we labeled it. So y2 is 5. The equation says minus. y1 is a negative 6. Now what Hannah did in the chat is she said, well, I have a negative 6 as my y1, so I really should be writing it in parentheses. And I could not agree more. She is absolutely correct. We are going to write that term in parentheses so that we don't lose the negative sign in front of the 6. x2 is a positive 2. Our formula has a minus here. And then x1 is a negative 3. So we're going to write that in parentheses. And now we're going to evaluate. 5 minus a negative 6. Well, minus minus, you know that's going to give you a plus. So 5 plus 6 is 11. 2 minus a negative 3, a negative and a negative make a positive. Think of it as multiplication, right? Negative 1 times a negative 3, right? Positive. So we have 2 plus 3, which is 5. And what do you know? Check. Yes, exactly. So what we ended up counting graphically by hand, we were just saying, let's move from one point to the next. So we counted that slope. We were able to prove that algebraically. I love it. I love it. I love it. Let's investigate what's happening with number 2. So for number 2, we have negative 4, 2 as our first ordered pair. And we have negative 4, negative 5 as our second ordered pair. So let's go ahead and plot both of these points. Negative 4, 2, so negative 1, negative 2, negative 3, negative 4, and then 2, it's a positive 2, so we went up. We are in quadrant 2. Then I have negative 4, negative 5. So again, left 4, but this time down 5. 1, 2, 3, 4, 5. Interesting. Okay, so let's connect these two with a straight line. So right off the bat, connecting those 2 points, we say, whoa, I have a vertical line. And because I have a vertical line, I actually know the equation of that line. We know that every vertical line is of the form x is equal to a number. Well, look at the 2 ordered pairs. Yes, look at the 2 ordered pairs. Notice that the x coordinates are the same. They're the same, which is pretty crazy, isn't it? Notice that the x in our first ordered pair is negative 4. The x in our second ordered pair is a negative 4. So the equation of this line, not that I asked for that, but we could provide it, and we might as well. The equation of this line is x is equal to negative 4. Pretty cool. So now I want to identify what's happening with slope. Okay, the tricky part about this is that we're neither rising nor falling, but we can pick one. So for instance, let's say that I called this one my first point. And I said, okay, well, if I wrote that slope is rise over run, and again, we're just doing this graphically. We're just looking at what's happening here. And if I said, okay, if I called this my first point and this one my second point, then I have to rise 1, 2, 3, 4, 5, 6, 7. But notice to get from this point to this point, all I had to do was rise. I did not have to run, which means my run is 0. If you took your calculator and you punched in 7 divided by 0, you're going to get error, which we know mathematically means that it is undefined. So there's a property here, vertical lines, that we have just uncovered. We can write every vertical line has undefined slope. And that's literally every time, okay? Every time we have a vertical line, we could say, oh, undefined slope, okay? Let's also prove this slope algebraically. I'm going to call my first ordered pair x1, y1, and I'm going to call my second ordered pair x2, y2. So let's use a formula. M is equal to y2 minus y1 over x2 minus x1. Again, I'm just going to rewrite it because it's good practice. Whatever it takes to get this to be completely a part of your being, right? I want this to be a part of you. Y2 is a negative 5 minus y1 is 2. Notice here that 2 is positive, so I didn't have to write a set of parentheses around that 2 because I wasn't worried about a double sign. Over x2, which is negative 4, minus x1, which is also negative 4. So this time I use parentheses. Negative 5 minus 2 is a negative 7. And then negative 4 plus 4 is 0. So even though our count is different, right? We're calling this your first point and you had to go down 7. That's what we've discovered here. These actually result in this same solution, which is that the slope is undefined. Okay? You should be able to do both things. You should be able to count that slope just visually, and then you should be able to calculate the slope algebraically. Go ahead and do number 3. You have your two ordered pairs, negative 3, negative 1, and 3, negative 3. I'll give you 2 minutes starting now. Okay, excellent, everyone. Hannah, Noelia, Ryan, Patrick, thank you so much for sharing all of your answers. So let's take a look at this. So negative 3, negative 1. So negative 1, 2, 3, negative 1. Here's our first point. I'm going to call that x1, y1. Our second point is 3, negative 3. So 1, 2, 3, down 3. 1, 2, 3. Perfect. I'm going to call that x2, y2. Let's connect with my straight edge, and I hope you're all using straight edges as well. I can't verify this, but I really, really hope you are. Draw arrows on either end. Okay, so when we read this graph, we notice that when we hit this, thank you, Ria and Kayla, when we hit the line, we're going downhill, right? We are moving downhill, which means we have negative slope. So we know that our slope is fall over run. So I'm going to write that here, that slope, in this case, is fall over run. Notice that that implies our slope is going to be negative. So as I move from the first point to the second point, I had to fall 1, 2. And then I had to run 1, 2, 3, 4, 5, 6. So I fell 2 and I ran 6. One of the things we always need to consider is that when we are writing fractions as answers, we always want to give reduced fraction form every single time without fail. So negative 2 over 6 reduces to negative 1 over 3. And that is our slope graphically, what we have found by simply counting. I want to prove to you that the slope of negative 1 over 3 actually does work. If you start at your first point, go down 1 over 3, 1, 2, 3, bam. I just found another point on the line. Go to this point, go down 1 over 1, 2, 3. Again, I have just discovered yet another point on the line. And you can continue to play this game, which is really cool. You're essentially just revealing points on this line, with integer coordinates, of course. Now we're going to calculate this algebraically. So we have y2, I hope you don't mind that I don't write the equation again. So y2, which is negative 3, minus y1, which is negative 1, over x2, which is 3, minus x1, which is negative 3. Negative 3 minus a negative 1, these two become positive. So negative 3 plus 1 is a negative 2. And then 3 minus a negative 3, well, that becomes a positive. So 3 plus 3 is 6. How cool, right? And that reduces to negative 1 over 3. Excellent. For those of you who use y1 minus y2 over x1 minus x2, you will get the same slope. I'm going to prove that to you right now. So what if instead I said, let's use y1 minus y2 over x1 minus x2. y1 is negative 1. y1 is negative 1. y2 is a negative 3. x1 is negative 3 minus x2, which is 3. Check it out. Negative 1 minus minus 3, well, that becomes a plus. So negative 1 plus 3 is a positive 2. And then negative 3 minus 3 is a negative 6, which again reduces to negative 1 over 3. I wanted to show you that you get the exact same answer, regardless of which point you call your first point or your second point. That's the beauty of calculating algebraically. I do want to point out that in this second example here of finding slope, we noticed that our negative was in the denominator, but we've also learned a long time ago that we're always going to write our answer with the negative either in front of the fraction or in the numerator. With slope, the numerator of the fraction will tell you whether or not you're rising or falling. Your denominator will always tell you how many places you are running. And remember, when you run from left to right. As you see in our notes here, the numerator will tell you whether or not you rise or fall. The denominator tells you how many units you run to the right. So even when we fell here, we still ran to the right. Even when we rose here, we still ran to the right. Okay? Now, Ria, I wanted to show you that you can flip these terms as long as you're consistent and you get the exact same answer. So I'm assuming, Ria, that you wrote your slope formula this form, which is beautiful. Perfect. It will always work. You'll always get the correct answer, writing it as y2 minus y1 over x2 minus x1. What I wanted to prove is that I could flip the order of those terms, y1 then y2, x1 then x2, and still get the same answer. So I wanted to show you that flexibility. Beautiful. Especially when you get into this more and more and you're thinking, shoot, which one has to be the first point and which one has to be the second? Well, nothing has to be first or second. It's really up to you, because you're calculating the slope between the 2 points. That's the beauty of it. Take a look at number 4. 0, negative 5, and 6, negative 5. I would like you to do the exact same thing that we've done for the previous problem here. But this time, let's try that in half the time. 60 seconds starting now. Please share your answers in the chat. Go for it. Lots of great answers in the chat. So let's break this down together. 0, negative 5. This is my first ordered pair, x1, y1. So 0, negative 5, 1, 2, 3, 4, 5. Here's 0, negative 5. And then we have 6, negative 5. I'm going to call this x2, y2. So 6, negative 5. 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4, 5. Plot these 2 points. Notice that when we connect these 2 points, we get a horizontal line. Whoops, look at me, writing all over my awesome straight edge. So we get our horizontal line. That means that we know this is of the form y equals. So if we were to think about what the equation of this line is, well, think about the fact that in both ordered pairs, the y-coordinate is the same. The y-coordinate is the same. So that means the equation of the line is y equals negative 5. That's pretty cool. So just by looking at this, we recognize the equation, must be y is equal to negative 5. So let's talk about slope. So slope is rise over run or fall over run. So I'm just going to say rise over run. Now, if we call this our first point and this our second point, well, to get from our first to our second, notice that we don't have to rise at all. We just have to run. So to get from the first to the second, we actually have 0 rise. But we have 1, 2, 3, 4, 5, 6 as our run. When you take your calculators, again, it's okay to punch it in. Punch it in, check it out. When you punch in your calculators 0 divided by 6, you get an answer of 0. So that means this time our slope is 0. Whereas before, when we had our vertical line, we had a slope that was undefined. And we made a note that, oh, every vertical line has undefined slope. We're about to make we're about to write a note about horizontal lines this time. So every horizontal line has slope equal to 0. Every horizontal line has slope equal to 0. If that concept is weird to you all, I like bringing up treadmills because a lot of us have gotten onto a treadmill. We've played around with it. We've increased the incline that, some of them are able to decline. So we played around with a treadmill, right? Okay. So imagine that you're first stepping onto a treadmill. When you step onto that treadmill, it's nice and flat. If you look at the little icon where it says incline, it'll say 0.0 because it's nice and flat. So we're assuming that the person who was using it before put it back to being completely flat, right? As long as they're respectful. So you step onto this treadmill and it's nice and flat. So 0.0 incline. But the second you start to increase that incline, the treadmill starts to lift, right? And actually I'll do it this way so that you look at me. So the treadmill is starting to lift, and notice that we have positive slope here. As we read from left to right, we have positive slope. So the further we increase, it gets steeper and steeper. Now imagine if I keep pressing that button, and we're going to pretend that the treadmill can do this, okay? Now imagine I keep pressing the button, and all of a sudden it's completely vertical. Are you going to work out on that thing? Are you going to work out on that treadmill that's completely vertical? No, you will not. Okay? You will not be able to. You are unable to work out on that treadmill. Vertical, slope which is undefined. You're unable to work out on it. It has a slope that's undefined. Going back to when you first step onto the treadmill, the slope is 0. It's nice and flat. So unless you're, unless you are imbalanced and you tend to topple over, you should have no problem walking on a flat treadmill, okay? So when it's completely flat, it's a slope of 0. But the second you start increasing it, your slope moves up like so. If, let's say, you had a treadmill, like my sister has one where it declines, so you can press a negative and it's as if you're going downhill, right? So it's like you're going down the side of like a mountain or whatever, or a hill, whatever you want to call it. Notice that the slope is now decreasing, meaning your slope is negative, okay? So you're falling before you're running, or, fall then run, decreasing slope. 0, positive slope, 0, decreasing slope. Hopefully that makes sense and is very clear. And again, if that treadmill is vertical, you ain't working out on that. Okay? It's not happening. That is undefined slope. Think about that. Play around with that in your minds. Hopefully that makes sense and you can remember that concept. Okay, so let's finish this off by calculating slope algebraically. M is equal to, so we have y2, which is -5, minus y1, which is also -5, over x2, which is 6, minus x1, which is 0. -5 minus -5, that becomes a plus. -5 plus 5 is 0. 6 minus 0 is 6. And then 0 divided by 6 is 0. So we have just proven algebraically that the slope is, in fact, 0. Okay? Think of a little person walking along that line. They can go for forever. When we had our previous example with our vertical line, if I put the person right up at the top, they're going to fall to their, deaths, basically, if they fall to the right of the line or the left of the line. There's no defined ground, so they're just going to fall. Or maybe they'll fall for forever. Okay? Hopefully that's helpful. The slope of every vertical line is undefined. The slope, I knew you would like that, Doc. I knew you'd like that, but it makes it easy to think about it that way. It really does. Nice and flat, no slope. Unless you're a klutz, you're not falling anywhere, right? Because there's no slope here, so it should be like, you know, no big deal. And then obviously when you have it vertical, you're going nowhere. So the slope of every horizontal line, right here, horizontal line, is 0. Those two are very different. So I've given you examples of each. Vertical lines come in the form x equals a number, and horizontal lines come in the form x equals, y equals a number. All right. When we meet again tomorrow, by the way, this was week 7, crazy, right? When we meet again tomorrow, we are going to get into parallel and perpendicular lines. So we'll explore that tomorrow. I would like to end class there. That was awesome. Continue to play around with the concepts related to slope. Practice calculating slope and make sure you're doing the associated assignment in Lumen so that way you can make sure you know exactly how to do it. Besides that, continue to ask any questions that you might have as we work through the material. And I will see all of you tomorrow for the continuation of our guided notes for Unit 4. Enjoy the rest of your day. Make the most of it. See you mañana. Bye.